You are welcome to chemistry class. I'm your host, Ajilore Olushola. In today's class, we shall be looking at the topic concentration terms. In the previous lessons, we've introduced ourselves to acid-base titration and we're able to define acid-base titration as a technique that is employed in volumetric analysis, which is an aspect of quantitative chemistry. We've looked at the procedures involved in volumetric analysis. We've also talked about how to determine the volume of acid that is involved in acid base titration. We've also talked about the indicators, choice of indicators used in acid base titration. In today's lesson, we shall be focusing on determining the concentration of a solution, be it the acid or the base. So our attention today is to talk about concentration terms. And here are the learning objectives for today's class. At the end of this lesson, it is expected that every student should be able to define concentration of a solution. You should be able to identify types of concentration and the units. Every student should be able to determine the concentration of a solution in gram per dm cube and mole per dm cube. And lastly, every student should be able to use a standard solution to determine the concentration of a solution of acid or base in acid-base titration. And here we're starting with the definition of concentration terms. The term concentration is used to describe the amount of solute which dissolves in a given volume of solvent. Okay, I want us to look at it from this perspective that every solution is formed as a result of combination of solutes and solvents. Now, the amount of solute which dissolves in a given volume of solvents must be measured in order to know the amount of substance dissolved in that solvent to form the solution. So a special terms that can describe this is called concentration. And that is why we are saying that concentration is used to describe the amount of solute which dissolves in a given volume of solvent. Now it can be defined in a more special way like this, that concentration is the amount of substance which dissolves in a given volume of solvent. Now I want you to take note of two things in this definition, because the two things are the main words in this definition. You have amount of substance. The amount of substance could be in number of mole, it could be in mass. Then you look at the volume. Of course, usually the volume is in dm cube. Even if the volume is in cm cube, this can be converted back to dm cube. So that is to say that the amount of substance and the volume are of great importance in describing the concentration of a solution. Concentration can be expressed in different ways. We have diverse ways of expressing concentration depending on the topic of discussion. We have different ways, as we can see in this next slide. Of course, we have what we call molarity, and this concentration talks about the moles of solute that dissolve in 1 dm cube of a solution, and that is why it's called molarity. We also have what we call mass concentration, which talks about the mass of solutes in a given volume of a solution. There's another one, normality, which talks about the grams of active solute per liter of a solution. Molality also talks about the moles of solutes per mass of solvents. We also have what we call the mass percent, which is the mass of solutes all over the mass solution times 100%. We also have what we call the volume concentration. This has no unit, and it is the volume of solid per volume of the mixture. We also have number concentration, which is usually the number of entities. It could be the number of atoms of a component divided by the total number of the mixture. We also have the volume percent, which is usually expressed in volume per percent. It is the volume of solute per volume of the solution multiplied by 100%. Like I said, there are different ways of expressing concentration of a solution. But for our level, we are going to focus on 2 ways of expressing concentration. And the 2 ways of expressing concentration for our level now is to look at molar concentration and mass concentration. So attention will be given to molar concentration and mass concentration. Now I want us to also look at concentration as being describing the sweetness of a solution. Suppose I have a cube of sugar in a 20 cm cube of water, and I have another 20 cm cube of water in another container with 3 cubes of sugar. Now we will notice that the second container is sweeter than the first one because you have dissolved more of solutes in that solvent. So, and as a result, we can say that the concentration of the second solution is more than that of the first solution. So we can say that concentration describes the sweetness of a solution. And the sweetness of a solution is the measure of the amount of substance that is dissolved in a given volume of that solution. The following terms are associated with concentration. We have the mass, which is usually in grams. We also have the volume and the numbers of mole. These 3 terms are so important when you are describing the concentration of a solution. I'll repeat: the mass in gram, in volume, and the numbers of mole. Now we are going to look at the relationship between these 3 quantities in our definition of mass concentration. Now mass concentration describes the mass of substance in gram which dissolves in a given volume of a solvent in dm cube. Mathematically, we can say that the mass concentration is given as mass over volume. So if you look at the unit will be gram per dm cube as a derived unit. So I'm going to keep this equation as equation 1. This formula is very important in acid-base titration calculation. So mass concentration is usually expressed in gram per dm cube. Okay, let's take this example. You have to calculate the mass concentration of a solution which contains 5 gram per 250 cm cube of a solution. Now you need to write out the parameters given. Of course, we are given volume. The volume is 250 cm cube. You have to convert this volume to dm cube. Yes, I'm aware that 1000 cm cube gives me 1 dm cube. Therefore, 250 cm cube will give me 0.25 dm cube. How do I arrive at this? I have just divided the 250 cm cube by 1000 cm cube to get 0.25 dm cube. So if you are converting from cm cube to dm cube, you simply divide by 1000, and here the volume is 0.25 dm cube. The mass of the solute here is 5 grams. So to calculate the mass concentration, we take the mass in gram all over volume in dm cube, as we can see. So if we divide 5 divided by 0.25, and that gives us 20 gram per dm cube, which is the mass concentration of the solution. I want to believe that this is clear to you. Don't forget, mass concentration measures the mass of the solute in gram per volume in dm cube. Okay, we're going to talk about molar concentration. Molar concentration is used to describe the amount of substance in mole which dissolve in a given volume of solvent in dm cube. Now, I want us to get it clear. In the previous definition of mass concentration, we said it described the mass of substance in gram. Here we are looking at the amount of substance in mole which dissolve in a given volume. So that is to say that molar concentration can be expressed in number of moles over the volume in dm cube, and we have the derived unit, which is mole per dm cube. So concentration is N all over V, where N is the number of mole. I'm going to keep this formula as formula 2. So molar concentration is usually expressed in mole per dm cube. Okay, now I want you to recall that number of mole is the same as mass over molar mass. So I'm going to keep this as equation of formula 3 because we might need this in calculation. Now, if you substitute for N in equation 2, N, which is our number of mole, in equation 2, my equation 2 is number of mole all over volume, which is the molar concentration. So if you substitute the value of N, which is mass all over molar mass, then you divide by volume. So we have concentration equals to mass all over molar mass divided by the volume. Now, I can as well write it as mass over molar mass times 1 over volume. So by rearranging, see what I'm going to get by rearranging. By rearranging, my concentration gives me mass over volume times 1 all over molar mass. So with this, I know that mass over volume gives me mass concentration. So I can represent mass over volume as mass concentration times 1 over molar mass. So if I combine this, then I have mass concentration all over molar mass, which is my molar concentration. So that is to say that molar concentration can also be expressed as mass concentration all over molar mass. So I'm going to keep this as formula 4. The above formula are used in determining the concentration of solution in acid-base titration. I mean formula 1 to 4, which I'm going to summarize below. So if you look at it, you have mass concentration, which is mass over volume. You have the molar concentration, which is number of mole all over volume. Then we also have the number of mole, which is mass over molar mass. Then the molar concentration that talks about the relationship between the mass concentration and the molar mass. Here we are going to take an example. A solution of sodium hydroxide was made by dissolving 4 grams of sodium in 500 cm cube of water. Of course, we are talking about sodium hydroxide in this question. 4 grams of sodium hydroxide in 500 cm cube of water. Calculate the concentration of the solution in gram per dm cube and in mole per dm cube. Okay, you need to write out the parameters given. We are given the mass, which is 4 grams, the volume, which is 500. You convert this volume to dm cube by dividing by 1000 cm cube, and that gives me 0.5 dm cube. Now the concentration in gram per dm cube is given as mass over volume. So if you do the mass over volume, you get 4 divided by 0.5, which is equivalent to 8.0 gram per dm cube, and that gives the mass concentration of the sodium hydroxide. Now to get the concentration in mole per dm cube, we have two ways of doing this. Now this is the first method. Get your number of mole, then you divide by the volume. Of course, the number of mole is given as mass over molar mass. The molar mass of sodium hydroxide in this question is 40 gram per mole. As we can see, the molar mass talks about the addition of the relative atomic mass of each element. Here you have sodium, which is 23, oxygen is 16, and hydrogen is 1. So you have a total of 40 gram per mole as the molar mass of sodium hydroxide. So hence the number of mole is given as 4 all over 40, which is equivalent to 0.1 mole. So knowing the number of mole, I can easily calculate the molar concentration using number of mole over volume. So I have 0.1 divided by 0.5, which is equivalent to 0.2 mole per dm cube. Now, another way of doing this is by saying molar concentration is equivalent to mass concentration over the molar mass. So once you have calculated the mass concentration, just divide it by the molar mass, you get the answer. So this method is even easier. So you need to decide on which of the formula to use depending on the parameters that you are given. So you can just say that your molar concentration is mass concentration all over molar mass. Since we know the mass concentration to be 8 gram per dm cube and the molar mass is 40, so we get our molar concentration, which is 0.2 mole per dm cube. Okay, we take another question. This is a little bit complex, and this is where we are going. Now I want you to take your time in studying how this problem is being solved. 25 cm cube of a solution containing 2 grams of sodium hydroxide per 250 cm cube required 20.5 cm cube of a solution of tetraoxo sulfate 6 acid for complete neutralization. Calculate the concentration of the acid solution in mole per dm cube and in gram per dm cube, and you are given the relative atomic mass of the elements stated. Now I want us to look at it that acid-base titration involves using a standard solution to standardize another solution. So for you to standardize a particular solution, it means to determine the concentration of the solution. So you must use a standard solution. A standard solution is a solution whose concentration is known. So if you look at it very well, that sodium hydroxide is a standard solution because we can calculate the concentration of sodium hydroxide because we are given the mass and the volume. So we can get the mass concentration, and once we have gotten the mass concentration, we can also determine the molar concentration. So by so doing, we know that sodium hydroxide is a standard solution. So we are required to use this standard solution of sodium hydroxide to determine the concentration of tetraoxo sulfate 6 acid. As you can see, we are not given the concentration in this titration, but we are given the volume of acid. So we assume that the titration has been done, and the average titer value, which is the volume of acid used here, is 20.5 cm cube. So to do this, the first thing to do, don't forget, I've given you 7 steps to doing this. Now don't forget, the first thing you need to do is to write the balanced chemical equation for the reaction. in order to determine the number of moles of the acid and the base. So here you have H2SO4 plus sodium hydroxide to give us sodium sulfate and water. As we can see, the equation is balanced as it is. The number of mole of acid is 1, while the number of mole of base is 2. Like I said, that sodium hydroxide is a standard solution. So the mass concentration of sodium hydroxide is given as mass over volume, which is 2 all over 0.25. Don't forget, I have converted the volume in cm cube to dm cube by dividing by 1000, and that gives me 0.25. So if I say 2 divided by 0.25, I'm going to get the mass concentration of the sodium hydroxide as 8 gram per dm cube. Now, after getting that, I need to get my molar concentration. So my molar concentration is usually the mass concentration over the molar mass. So I can take the mass concentration, which is 8, and of course I know that the molar mass of sodium hydroxide is 40. So I'm going to say 8 divided by 40, and that gives me 0.2 mole per dm cube. And that is the concentration of the sodium hydroxide. But that is not what we are asked to look for. Don't forget, we want to use that sodium hydroxide to standardize H2SO4, that is, to determine the concentration of tetraoxosulfate 6 acid. So we need to list out those parameters that were given in the question. Of course, we have the number of mole of the acid, which is 1. Of course, you get this from the balanced chemical equation. That of the base NB, which is 2. You could see that sodium hydroxide requires 2 mole. Then you have the volume of the acid as the average titer value, which is 20.5 cm cube. The volume of the base, which is the volume of the pipette, which is 25.0 cm cube. Here we are to determine the concentration of the acid, which is Ca. We have to determine it in mole per dm cube and in gram per dm cube. Now, recall that at endpoint, Na over Nb is equivalent to Ca Va divided by Cb Vb. That is, at endpoint, the ratio of the number of mole is a given constant, which is given as Ca Va over Cb Vb. So because we are looking for Ca, we can cross multiply. If we cross multiply, we have Ca Va Nb, which is equivalent to Cb Vb Na. So eventually I can divide both sides by Va all over Nb, and that gives me the Ca. I'm going to substitute the appropriate value, and I'm going to get the concentration of the acid in mole per dm cube as 0.122 mole per dm cube, and that gives me the concentration of the acid solution in mole per dm cube. Of course, I can always convert this to gram per dm cube. Concentration of the acid solution in gram per dm cube. So what we need to do is to make mass concentration the subject of the formula, and that will be mass concentration is equivalent to molar concentration times molar mass. Of course, the molar mass of tetraoxosulfate 6 acid is 98 gram per mole, and that has been calculated as seen here. We have hydrogen, which is 1 multiplied by 2. We have sulfur, which is 32, and oxygen, which is 16 multiplied by 4. So we have 2 plus 32 plus 64. That gives 98 grams per mole. So the mass concentration is given as 0.122 times 98, which gives 12.0 gram per dm cube. And that is the mass concentration of the acid solution. It implies that 12 grams of the solute has been dissolved in 1 dm cube of the solvent. And I think that will bring us to the end of today's class, and here are practice questions for you. So I want you to look at this question very well. Now, in this question, you are expected to calculate the concentration of the acid in mole per dm cube for question 1, and for question 2 it is a little bit trickish, but I want to believe you can apply the same principles and you're going to get your answer. Here you want to look at the concentration of unknown base and you have to look for the relative atomic mass of element X, then name the element. You have to submit this assignment via WhatsApp to the numbers stated here. So to submit this assignment at least 24 hours after listening to this PowerPoint slides and voiceover. Wishing you all the best. Thank you for your time. I am your host, Ajilore Olushola.